We're going to run through this practice problem. As is true with all practice problems, I recommend that you pause the video, read the problem, work the problem on your own, and then watch the video which discusses how we go about doing it. All right, so let's check ourselves here and make sure that we understand what all's going on with this problem. First of all, you notice it's saying that it's going up by 11% a year. So that tells me that I'm going to be doing this as annually compounding interest. And the percent tells me that it's compounding interest, and the a year part tells me that it's going to be annually compounding interest. So I'm using this equation, the very first one that we wrote down of our compounding interest equations. And now it's just a matter of plugging all the little pieces into the right place. All right, so first thing that you notice is that I'm going to be writing a of t. Now my t value here comes from the fact that we got this when we turned 18, but that we're going to leave it there until we turn 60, which means that our t value then is going to have to be 42. All right, next up, p, my principal value. That's our starting amount, so that's the 1,000. Then we go to our r value, and r here is going to be my rate, 11% as a decimal. So I'm going to take the 11, I'm going to divide it by 100, which is going to give me 0.11. And then the t here is the same as the t here. That's also going to be the 42. And so this is going to be our general equation. Now it's just a matter of doing the calculation. I want to do whatever's inside the parentheses first, and then I'm going to raise that to the power and multiply it by the number out front. And so in this case, that gives us an answer of about $80,087.57. And in case you're curious, yes, these are real types of numbers that can really happen and that are very realistic and possible. So it's a matter, of course, about what your investments actually pay a year, but anywhere between 10 and 12% is doing pretty well. And so that's why I kind of used 11 on this one. But it shows that $1,000 just put into an account and left for 42 years can grow to be 80 times as much. Now let's add one little twist to this question. What if this gift were given when we were born instead of when we turned 18? How would that change things up a little bit? Well, in terms of our original equation, the 1,000 wouldn't have to change at all because we're in the same amount. The rate wouldn't change at all because we're assuming the same average. The only thing that is changing here is the time value. Instead of it being in there 42 years from 18 to 60, it's going to be in there from birth to 60, which is, of course, 60 years. And so now we can go ahead and do that calculation. And when you do that one, we end up with $524,057.24, $500,000. That turns out to be quite a nice gift, doesn't it? And certainly a nice thing that you can do if you ever find yourself able to in life. And it's also a reminder that if we are fortunate enough to have been given such a gift when we were young, leave it there. Let it grow. You'll be glad you did later.